Hi, in this video, I will be showing you problem number 43 of chapter 2 section 5 from the practice exam. For each x value at which f is discontinuous and for each x value, determine whether f is continuous from the right or from the left or neither. F of x is a piecewise defined function which is x plus 4 if x is less than 0, e to the x if x lies between 0 and 1, 0 and 1 inclusive, f of x equal to 4 minus x if x is more than 1. We'll graph this as follows. So you see that x is strictly less than 0. So it is a linear equation which is a straight line, which is a line x plus 4, the y-intercept is 4, but it doesn't go up beyond 0. So at 0, you don't have an equal to sign, strictly less than 0. So it ends at 0. When x equal to 0, y equal to 4. So there is a hole at 0, 4. There is a hole at 0, 4. So it's a straight line that stops at 0 with a hole at 0. Then it is e to the x, which is an exponential function, in the interval 0 to 1, both 0 and 1 inclusive. So if you look at this graph e to the x, so it's a piece of that piece is exponential function. When x equal to 0, the lower value of the interval, it is e to the 0, which is 1. So when x equal to 0, y equal to 1. When x equal to 1, the upper end, when x equal to 1, it is e to the 1, so it is 1, e. So it is slightly more than 2, so which is between 2 and 3. E is a number between 2 and 3. So it is taking up this piece e to the x graph. Now, when x is more than 1, it is 4 minus x. So the slope is negative. The y-intercept is 4. So if you draw the full graph, you have to cross it through 4, but it is starting only after 1. So when x equal to 1, it's actually not defined. It's actually when x equal to 1, y equal to 4 minus 1 from the last, 4 minus 1, which is 3. So x is 1, y is 3, but there is a hole because here we don't have equal to sign for x. So x is strictly more than 1. So there is a hole at 1, 3. And then it's a decreasing function, which is a straight line because it's also 4 minus x, which is a linear equation with slope equal to negative 1 and y-intercept equal to 4. Okay, so we get that green piece of the graph. Now we have to see where this function is discontinuous, and also we have to say where it is continuous from the right or left. First we notice that f of x is a linear equation which is a polynomial in the interval negative infinity to 0, and it is again a polynomial which is a linear equation in the interval 1 through infinity. So the first piece is a linear equation polynomial continuous. The last piece is also linear, which is a polynomial and continuous. So it is continuous. F of x is a polynomial on negative infinity through 0 and 1 through infinity, and hence continuous on these two intervals. Also, f of x is exponential on 0 through 1 and is continuous. It is continuous on 0 through 1. Now, where is it discontinuous? So from the definition of the graph, we can kind of guess that it should be discontinuous at 0 and discontinuous at 1. We will prove it algebraically anyways. So also in the graph, it shows that there is a discontinuity at 0 and there is a discontinuity at 1. So we will prove this algebraically or calculus way. So let's consider limit x approaching 0 plus f of x, which is limit x approaching 0 plus, so it is slightly more than 0. Slightly more than 0, it behaves like e to the x. So it is equal to e to the 0, which is 1. And what is f at 0? F at 0 is also e to the 0, which is equal to 1. So it is actually right continuous at 0. But also, so because we notice here, limit x approaching 0 plus f of x is same as f of 0. So the function is continuous from the right, or right continuous. At 0. But is it continuous at 0? So limit x approaching 0 of f of x. You should treat this as two limits, one from the left, one from the right. So limit x approaching 0 minus f of x is limit as x approaching 0 minus. To the left of 0, it behaves like x plus 4. So it is equal to 4. And it is not equal to f at 0. And therefore it is not continuous. F of 0 is equal to 1. So it's f of x is discontinuous at x equal to 0. It is discontinuous at x equal to 0, but it is right continuous. So we have discussed when f of x is, we have discussed the case when x equal to 0. We have to discuss the case when x equal to 1. So limit is x approaching 1 from the right of f of x. So limit is x approaching 1 from the right, 1 plus 4 minus x, which would be equal to 4 minus 1. You're plugging in x equal to 1. That will be a 3. But f at 1 equal to e to the 1, which is e, which shows that limit is x approaching 1 plus of f of x, which we proved to be equal to 3, is not equal to f at 1, which is equal to e. So this shows clearly that f of x is discontinuous at x equal to 1. Now, we will try to prove that it is left continuous at 1. So what happens? Limit as x approaching 1 minus f of x. So it is limit x approaching 1 minus, to the left of 1, it behaves like e to the x. So you have to plug and place. So it is e to the 1, which is equal to e. But what is f of 1 though? F of 1 is again e to the x replaced by 1, which is again e to the 1 e. So this shows that f of x is left continuous at 1. So we have proved two things. So in conclusion, we can say f of x is discontinuous at 2 points, namely x equal to 0 and x equal to 1, but it is right continuous at 0, right continuous at x equal to 0, and left continuous at x equal to 1. It's evident from the graph though, but this is calculus way of proving it. Hope this video